Hey everyone, welcome back to another video. So today we have another AP Microeconomic FRQ to review for the AP exam. This one has to do with Unit 2. It's a pretty quick one too. So it says backpacks are produced in a perfectly competitive market with no externality. So you know it's not Unit 6 and is a market and supply curve for the backpacks in the country of Jambo. So just a regular supply and demand graph. Cool. A says calculate the total economic surplus at the market equilibrium. Show your work. So we know the total economic surplus is just this triangle here. So, I mean, what you could do, I suppose, is break it up into your consumer surplus, which is the difference between what consumers are willing to pay and what they actually do pay. So if our market equilibrium price is $90 and some guy is willing to pay $150, they get that $60 as consumer surplus, and then that's multiplied throughout for all the price levels down to the down to the equilibrium price, and then multiply throughout for the quantities as well. And you would add that to the producer surplus, or you can just calculate this entire triangle right here. So that's what we're going to do. So we know that to calculate the area of a triangle, it's 1/2 base times height. So we're going to have 1/2 times the base. So what is the base of this triangle? I'm going to look at it from the price. So the price here you can see goes from 30 to 150. So 150 minus 30, that is $120. And then we have to multiply it by our quote-unquote height, which is really our quantity in this case. So we go from 0 to the equilibrium quantity, which is 16. So we multiply this by 16, and we should get a value of $960 as our economic surplus. Okay, cool. So that is A. B wants us, it says, to decrease the price of backpacks for students, the government of Jambo decides to set a price ceiling of $60 per backpack. Still pretty darn expensive. Compared to the market equilibrium, will the quantity of backpacks purchased increase, decrease, or not change as a result of the price ceiling? Well, let's see. Theoretically, you would think that if the price goes down, they would buy more. But is that the case? Well, this is a price ceiling below the equilibrium price, which means it is binding and does have an effect. So consumers, right here, they want to buy 24 backpacks. But consumers, producers, they're like, hey, we used to be able to sell these for $90. Now we only get $60. We're getting screwed over, and so they're going to produce less. So here you can see they only produce 8 backpacks. So consumers want to buy 24, but they can only buy 8 because they're limited by the amount that the suppliers actually produce. And so down here, when it asks what will happen to the quantity of backpacks purchased, the quantity of backpacks purchased will be decreased, because consumers are limited to how many backpacks the suppliers, okay, this one on screen, suppliers will produce, which went from, so our equilibrium was 16, went from 16 backpacks to 8. So that limits how much producers can buy. All right, cool. Let me just erase all this mumbo jumbo. Dang, okay, cool. Let's move on to part C. It says, suppose instead the government of Jambo provides a per unit subsidy of $30 to the sellers of backpacks. So each unit, the government is basically going to give $30 to help support these suppliers. Okay, so what happens then is, well, you might think, well, what happened to the actual price is a decrease in the price. Now, theoretically, if you think about it, the business could just take that subsidy and continue to charge their current price, right? Like, let's say this guy down here, yeah, he's selling it for $30, and if he gets that subsidy of $30 from the government, I mean, he can keep charging $30. But what's going to happen eventually is just supply and demand, right? Other businesses are going to get that subsidy, and they're going to charge less for it, and consumers are going to see that guy charging less for it and start buying that guy's products, and so the other guy is forced to decrease his prices by that per unit subsidy, and you get back to equilibrium. But let's see what would actually happen. So it's just a per unit subsidy. So this per unit subsidy will cause a decrease, not a decrease, but a shift of the supply curve. Okay, and that supply curve is going to shift to the right. Essentially a quote unquote increase in the supply, right? Because now it is technically cheaper to produce these backpacks because you get $30 from the government for each unit you produce. And so if we were to draw the graph here, we get 30, right? We have 30, we can match it up. Minus 30 would be down here to 0. And then let's label another critical point. So we have 60 originally, so we can go down here to 30. And let's do at equilibrium 90, so that would be 60. And let's do another one, 120. That would be at 90. And so we can draw pretty confidently a graph that goes through like this. Maybe I should get out a ruler. And, okay, wait, never mind. We're not using the ruler. We're just going to have to free draw this, and hopefully it looks pretty respectable. That's not a great line. Just imagine that as a straight line. C says identify the price paid by consumers per backpack after the per unit subsidy is implemented. So now that we have a new supply curve, what happens is we have a new equilibrium price and quantity, right? So that intersection, let's call this supply 2. That new intersection is right there, and we can see the new equilibrium. We're trying to find the new equilibrium price for consumers. We go over and see it is $75. And so that right there is $75. Part C of C, well, it's kind of weird. Calculate the total cost of the subsidy to the government, show your work. So how much is this going to cost the government? Well, we have to find out how many backpacks they are providing the subsidy for, right? Because it's a per unit subsidy. So we can see here at market equilibrium, the suppliers will produce 20 backpacks, okay? So we have 20 backpacks, right? And remember, the government is supplying $30 per backpack, right, to cover costs. So that we're going to multiply that by 30. And that gives us a cost to the government of $600. All right, let's move on to the last part of C. It says, does the per unit subsidy cause a deadweight loss to increase, decrease, or remain the same compared to the market equilibrium? In part A, explain. We know in part A that the deadweight loss is 0, right? Because we're producing at the allocatively efficient quantity, which is 16. But at this new value after the subsidy, we're producing 20, right? People want 16, but now we're producing 20, which means we're not producing at the allocatively efficient point, and we're losing efficiency somewhere there, right? Where are we losing that efficiency? Well, it's right here represented by this box right here. Let's shade that in blue. That is our deadweight loss for our graph after the subsidy, okay? So it wants us to explain. So we will say increase because the new, oops, if I can spell, equilibrium quantity produced is greater than the, I'll move this up, greater than the allocatively efficient quantity. Okay, so we're not producing at the allocatively efficient quantity, and therefore we have deadweight loss, meaning if we have 0 deadweight loss to begin, deadweight loss must have increased. So that does it for the entire FRQ. Make sure you guys subscribe for more videos just like this, and I'll see you guys in the next video.